Imagine a world where the concept of a computer was as alien as talking with someone across the globe in real time. A world where every calculation was a laborious task undertaken by hand, and progress crept forward at the pace of human endurance and intellect. Less than a century ago, this was reality, a time when the word computer referred not to a machine, but to a job title. Human computers, predominantly women, performed complex mathematical calculations, often working in large teams to process data for scientific research, engineering, and military needs. The demands of World War II pushed the limits of human computing, revealing the critical need for speed and precision in calculations that human brains simply could not match. Armies required rapid computation to determine trajectories, engineer new weaponry, and solve logistical puzzles that outpaced manual methods. Delays and errors could mean the difference between victory and defeat. The world was at a technological crossroads, and the solution lay in a revolutionary concept: a machine that could perform calculations faster, more accurately, and tirelessly. Enter the era of electronic computing, where visionaries and engineers began to dream of a device that could execute thousands of calculations per second. The groundwork for this technology was laid in the 1940s, when a team of engineers embarked on an unprecedented project to create what would become the world's first general-purpose electronic computer, the Electronic Numerical Integrator and Computer, or ENIAC. ENIAC was a behemoth of a machine, a testament to the ingenuity and ambition of its creators. It stretched over 1,800 square feet, weighed more than 27 tons, and consumed as much electricity as a small town. Its heart was composed of 18,000 vacuum tubes, each one essential to its operation and each one a potential point of failure. This massive humming giant was a far cry from the sleek, silent devices we slip into our pockets today. The sheer scale of ENIAC was both its strength and its Achilles heel. Programming it involved the physical rewiring of cables and switches, a task that could take days. Yet, once set into motion, ENIAC could perform in seconds what had previously taken teams of human computers days or even weeks to achieve. Its speed and efficiency marked a seismic shift in the capabilities of technology, heralding the dawn of the digital age. But what truly set ENIAC apart wasn't just its mechanical prowess. It was the people who brought it to life. Behind the clatter of switches and the glow of vacuum tubes was a team of unsung heroes, the programmers who breathed life into the machine. In a time when computing was a nascent field and when women's contributions often went unnoticed, these pioneers were instrumental in shaping the future of programming. These programmers, many of whom were women, operated without the benefit of guides or manuals. They learned through trial and error, developing the earliest forms of programming logic from scratch. Every day, they faced the challenge of understanding and manipulating a machine that seemed more like an unruly beast than a tool. Their efforts laid the foundation for modern software development, and their innovations continue to echo in the programming languages and methodologies we use today. As ENIAC roared to life, it did more than just calculate numbers. It demonstrated the potential of machines to augment and surpass human abilities in processing information. This moment was pivotal. It suggested a future where machines could take on tasks previously deemed impossible. From ENIAC's towering presence, the seeds of future technological marvels were sown. Smaller, more efficient computers. The rise of personal computers revolutionized how we work and communicate. The expansive networks of the internet, and eventually, the powerful smartphones that have become integral to our daily lives. ENIAC was not the culmination of the digital journey, but its beginning, a monumental leap that reshaped expectations and possibilities. The concept that machines could handle complex computations far beyond human capabilities was a revelation that spurred continuous innovation. It set the stage for advancements that have led to the interconnected world we navigate today. Information flows seamlessly across borders and devices, touching every aspect of our lives. As we embark on this exploration of ENIAC's legacy, we uncover the roots of our digital existence, tracing the lineage of technology from a room-sized giant to the palm-sized devices of today. This is a story of transformation, of human ingenuity, meeting the relentless march of progress. And it begins with a machine that, though it filled an entire room, opened up worlds of possibility. The advent of ENIAC marked a turning point, not just in technology, but in how societies approached problems of scale and complexity. In the years following its unveiling in 1945, ENIAC became a symbol of computing power and the limitless potential of human innovation. Yet, to fully grasp the impact of ENIAC, it's essential to delve into the intricate web of circumstances and individuals that shaped its creation and legacy. ENIAC's development was spearheaded at the University of Pennsylvania by John W. Moseley and J. Presper Eckert. Moseley, a physicist with a keen interest in electronics, had long been fascinated by the potential of machines to perform calculations. His visionary ideas found a practical collaborator in Eckert, an electrical engineer whose expertise in electronic circuits helped bring Moseley's concepts to life. The project received funding from the U.S. Army, driven by the urgent wartime need for rapid artillery trajectory calculations. The collaboration between military needs and academic innovation was crucial to overcoming the technical challenges that lay ahead. The complexity of ENIAC's construction was staggering. It required a team of engineers and technicians who spent countless hours soldering connections and troubleshooting circuitry. As ENIAC took shape, another crucial aspect of its story unfolded: the role of the computers, the women who programmed the machine. 6 women, Kathleen McNulty, Frances Billis, Jean Jennings, Marlin Westkoff, Ruth Lichterman, and Betty Snyder, were selected from a pool of human computers. These women, pioneers in their own right, were tasked with the monumental challenge of programming a machine that had no precedent. Programming ENIAC was an art and science unto itself. Without software as we know it today, the women had to physically set up the machine using plug boards and switches to configure its operations. They developed the first algorithms, learning to optimize ENIAC's capabilities by understanding its quirks and limitations. Their work was not just a technical achievement, but a profound exercise in creativity and logic. This laid the groundwork for the disciplines of computer science and software engineering. Despite their pivotal role, the contributions of these women were largely overlooked for decades. It was not until much later that their achievements were recognized. This shed light on the gender dynamics of early computing and the critical role women played in shaping the field. Their story serves as a reminder of the often unseen contributions that have driven technological progress. With ENIAC operational, its capabilities quickly captured the imagination of scientists and engineers across various fields. It was not long before the machine was pressed into service for complex calculations that spanned disciplines, from weather prediction to atomic energy studies. ENIAC's ability to process data at unprecedented speeds transformed scientific research. This enabled breakthroughs that had previously been hindered by computational bottlenecks. ENIAC's influence extended beyond its immediate applications. It inspired a generation of engineers and scientists to imagine new possibilities for computing. Among them was John von Neumann, a polymath whose contributions to a wide array of scientific fields are legendary. Von Neumann's involvement with ENIAC led to the development of the stored program concept. This concept involves storing instructions and data in a computer's memory. It's a fundamental principle that underpins modern computing architectures. As successors to ENIAC began to emerge, the lessons learned from its construction and operation informed the design of more efficient machines. The transition from vacuum tubes to transistors and eventually to integrated circuits led to exponential increases in computing power. This also led to reductions in size. The trajectory from room-sized behemoths to desktop computers and beyond was set in motion. It was fueled by the momentum that ENIAC had generated. ENIAC's legacy is not just one of technological achievement, but of human creativity and perseverance. It demonstrated that with the right combination of vision, resources, and talent, seemingly insurmountable challenges could be overcome. This realization propelled the field of computing forward. It fostered a culture of innovation that continues to thrive today. As we trace the lineage of modern technology, it becomes clear that ENIAC was more than a machine. It was a catalyst for change. Its impact reverberated through the decades. It influenced everything from the development of early mainframes to the personal computers that revolutionized the way we work and communicate. The echo of ENIAC's creation is present in every byte of data processed by the devices we use daily. This is a testament to the enduring power of its pioneering spirit. As ENIAC blazed the trail for electronic computing, it left behind a legacy that was both profound and expansive. The post-war era witnessed an explosion of interest in computing technology. Governments, universities, and private enterprises were eager to explore the possibilities that ENIAC had unveiled. The success of ENIAC catalyzed the rapid development of subsequent computers. Each was more powerful and compact than its predecessor. One of the most significant successors was the UNIVAC I, the first commercially available computer in the United States. Developed by the same team behind ENIAC, Eckert and Moschly, UNIVAC I was designed with business applications in mind. This marked a shift in the perception of computers from military and scientific tools to indispensable assets for commerce and industry. In 1952, UNIVAC I famously predicted the outcome of the U.S. presidential election. This heralded a new era of data processing and analysis. The ripple effects of ENIAC's innovations reached far beyond the confines of academia and industry. The machine laid the groundwork for the burgeoning field of computer science. It encouraged the establishment of dedicated research programs in universities around the world. These programs nurtured a new generation of scientists and engineers. They would go on to develop the technologies that define our modern digital landscape. The influence of ENIAC can also be seen in the cultural shift towards automation and digitization. As computers became more accessible, society began to envision a future where machines could perform tasks ranging from mundane to complex. This vision drove the development of early artificial intelligence research. Scientists sought to create machines that could learn, reason, and adapt. Moreover, ENIAC's legacy is intertwined with the rise of the Internet. The ability to process and share vast quantities of data laid the foundation for the interconnected world we inhabit today. As computing power increased and network technologies advanced, the dream of a global information network became a reality. This transformed communication, commerce, and culture. The spirit of innovation and collaboration that characterized ENIAC's creation continues to inspire technological advancements. Modern computers, from the most powerful supercomputers to the smartphones in our pockets, owe their existence to the pioneering work of ENIAC's creators. The machine's influence endures in every line of code and every circuit. It serves as a reminder of the audacious leap that began the digital revolution. As we reflect on the journey from ENIAC to today's cutting-edge technologies, we see a testament to human ingenuity and the relentless pursuit of progress. The story of ENIAC is not just about a machine, but about the people who dared to dream of a future where technology could extend the boundaries of possibility. ENIAC was the spark that ignited the digital age. It was a beacon of what could be achieved when vision met determination.